Now, when we talk about sets, we're going to sometimes have sets of primitive types, and we're sometimes going to have sets of objects. We need to be able to support both. So when a set holds an object, then typically what we do is we associate with that object a key that's used to uniquely identify the object. So for example, if I'm representing students, then I might use the student ID number as the key to uniquely represent a student, because that ID number is a proxy for everything else we know about that student. The student will also have a name, and will also have a major, will also have a GPA and a lot of other stuff, but that ID number will be unique, and only one student has that ID number. So that ID number is a good key to use for a student. If we were talking about citizens of a country, like for the United States, then a social security number is a similarly good piece of information. Oftentimes, a key is actually one of the fields that's in the object. But it doesn't have to be. It could be a property of multiple fields put together that we calculate using a function or method. Here's an example. Suppose the items in a set are dates of historical significance. Like maybe I have this class over here to the right where that represents historical dates, and I have a string that explains what the date is. And then I have a year, month, and day that tells me when it happened. Okay, and then over here, I'm showing you some things I might want to store in this set, like June 15th and 12/15. I think that was the signing of the Magna Carta, if I did my research right and copied the date correctly. The next one I'm confident of, July 4th, 1776, was the signing of the Declaration of Independence, our independence from Britain. And December 6, 1865, that was when the 13th Amendment to the Constitution was ratified. So these are some important dates. And I might want to stick these dates, these historical dates, in a set to keep track of them. And so then I'm going to need a key. So I could add a method to this class called getKey that returns a piece of information about this historical date that sums it up, right? And so one option would be I just take one of these fields like year and say that's the key. The problem is year isn't very unique for a date, right? Because there are 365 days in a year. And if I use year as the key, it means that I can only have one event per year. That's kind of the insinuation, right? Keys should be unique for the object they represent. And I don't want to be forced into only having one historical event per year. So that's not really a good key. Maybe it would work for some set of historical dates, but it may not work in general. So the key plays a big role in sets of objects. We're going to use the key in several ways. When we're dealing with objects, we'll use the key to perform ordering. Like that key may need to support a less than operator so that we can decide their ordering in a set. For insertion, we'll just check to see if keys are equal. And if the keys are equal, then if a key that we want to insert is equal to an object that's already in the set, then we don't insert it. But if the key is not equal to any object in the set, then we will insert it into the set. Right? When we do a find, we'll actually use the key to decide when we find a match. And likewise for remove, we'll remove any object that has a matching key. So like back to that previous slide, if I only use the year, then only using the year would mean that I would remove anything that matched the year. And so, that could be good, but it may not be exactly what you would want. Here's some other examples of how we could order by key our historical dates. We could use the month, day, year, or the significance as the key. So if I use the day as the key and then I ordered my set, then July 4th would come first because 4 comes before 6 and 15, and then the 13th Amendment would become second in my list, and then the signing of the Magna Carta would come last. So that's kind of a weird ordering. Likewise, I could order by year from smallest to largest, in which case the signing of the Magna Carta comes first, then the Declaration of Independence, and then the 13th Amendment. I could even sort by the string. And in that case, I'm not sort. I could use the string as the key. And if I use the string as the key and I ordered by the string, then I would actually maybe order based on alphabetical order of the strings. So what I pick as the key, affects many things in the operation of the set. Maybe even better is to use all of the fields together to say, like, for two objects to be the same, they have to have the same year, the same day, the same month, and the same string. And if they match all of those, then they're the same. That would actually be the best key, to say the whole object together is the key. And this is an example of using multiple fields at the same time. Like if I needed to compare two keys, then I could look at all of the fields. I don't have to just pick one field. So for example, if I pass in on the historical dates object, I could provide an operator less than and pass in another historical dates. And then I could compare year to other.year. And if that's less, then I know that this historical date comes before that one. But if they're equal, then I need to look at the month. And if the year and month are equal, then I need to look at the day. And then if the year, month, and other are equal, then they're the same day. Okay, so if we have sets on primitive types, then we can also imagine we have a key. It's just that we don't really need a key, but what we'll do is we'll pretend like the key for a primitive type is just the primitive value itself, right? So if I have a set of integers, then I'm just going to use the integer as the key. If I have a set of doubles or strings, I'm just going to use the string as the key. It's also worth pointing out that I could also have a set of pointers. And pointers are a primitive type. Pointers are basically integers. So if I wanted to have a set of objects or a set of addresses of objects, that would also be okay. And in that case, I would just literally use the address of the object, as the key. And as long as I don't try to insert the same object into a set twice, then, the set will represent, I can try to insert the same address twice, but it will just get ignored, right? Because I can only hold it one time in the set. Okay, in summary, when a set holds objects, a key is used to uniquely identify the object. And a key can be a field in the object or a property computed from the fields, or it could somehow encompass all the fields of the object. That's okay. The choice of key is important. If the choice of key limits the number of unique values, then it could affect the meaning or the utility of your set. So you want the key to be really reflective of the whole object as much as possible. So like a student ID number is a very good key for an object representing students. But for historical dates, it would really make the most sense to use all of the information in the object, both the year, month, day, and the significance.